Okay. Hi, everyone. Thanks for joining us for our workshop. Before we begin, I'm going to start with a land acknowledgement. So we wish to acknowledge this land on which the University of Toronto operates for thousands of years has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous peoples from across Turtle Island, and we are grateful to have the opportunity to work on this land. And with that, I'm going to turn it over to Kwan to introduce our speaker for today.
Thank you, Aya. It's an honor to introduce Matt. So Matt is a general surgery resident and PhD candidate in clinical EPIC program at the University of Toronto Institute of Health Policy Management and Evaluative Science. So his research interest is using ICES data to evaluate wait times in young adults with cancer. Matt has recently received the University of Toronto Student Leadership Award for his work in organizing and leading the Our Interest group at IHPME. So we'll have Matt take over the floor and talk about ggplot with us today.
Thanks so much. I'm going to try and share the screen. Okay, can everyone see that? That's working okay? Yes? Okay, perfect. So today we're talking about ggplot and specifically how to take ggplot beyond sort of single nice plots that may be publication quality, but aren't necessarily at the level that are going to be highly useful for a publication. So the overview, I have no conflicts of interest. And I geared this talk towards people that are somewhat familiar with ggplot. You may be using ggplot to make all of your nice figures, and you're quite comfortable making a single clean figure that you can export that's high quality. But now you're amassing all of these figures as you're doing your analysis. And then when you're looking at the requirements for your manuscript, you are typically allowed 5 to 8 tables and figures, and you need to go that extra step of wanting to put more information in your plots in a way that's readable. You want to start adding panels, you want to have subplots, text annotations, just a way to take your figures to the next level so that you can actually include them in the manuscript. So the goals of this are to simply review the structure of a ggplot as a review. We're going to talk about aesthetics and annotations, and then simple and complex faceting. And then finally, how to arrange panels, including inset tables, so that you can show multiple different types of data at the same time. So here are the libraries I'm going to be working with, and I'll have these slides posted. So you should be able to recreate all of these plots. So as a brief review of ggplot2, essentially, there are many sections to ggplot and a lot of customization, but fundamentally what you're doing is taking your data set and you're mapping some of your variables to either axes or aesthetics, so an x-axis, a y-axis, something you want to demonstrate through color or size. You lay that all out and then sequentially adding layers that will show information on your plot according to the variables you've mapped. So I want to show points, I want to show lines, I want to show box plots. And then as a final step, you take that sort of basic plot and you start to customize it. And you can really kind of go crazy at this level in terms of changing axes and changing colors and all those sorts of things. So if we have a very simple data set here, and I like this style of doing it where you show the data set and then pipe it into ggplot, you may often see people put a statement here with data equals data set. And the benefit of doing this is you can clean data and then create your ggplot all in the same chunk of code. So in between these two steps, you can manipulate variables, and it just makes it a little bit more efficient. So you're creating less kind of temporary data sets for every plot. So even in simple examples, I try and always keep this structure of data set and then piping into ggplot. And here we're mapping our variables in a very simple example. My x-axis is an x variable. My y-axis is a y variable. And when I display this, nothing is there because it's essentially an empty plot, but it does show the labels of x and y. So now I can add layers. So I've added 2 layers here, a point layer, and geom stands for geometry, and a line layer. And you don't really need to add any more information because they're inheriting everything that you've put in this top line of x and y. So here are my points and then the lines. And as a third step, you can customize it now. So I've used this labs argument and I've put a title. I've renamed my X and Y axis. I've given it a title. In the theme, I've changed the base size of all of the font. I've removed some of the grid lines in this theme here. And I've added some customization to the points and the lines here. I've changed the color and the size. The line type argument in geom line will create a dashed line. So, this is a level you might be familiar with, and this is what you're already doing, but it's not very efficient if you only have 3 sort of key figures to display just a simple figure like that when you can do so much more. And it's always important to save. One of the benefits of using ggplot is it's trivial if the paper you're submitting to wants something as a PDF or an SVG file. You can just change a few arguments in here and get nice high quality figures that don't require a lot of manual editing. So I think the first place to start is, can you add more information to the plot you've already made using aesthetics and annotations? So before you think about splitting something into a panel or into facets, sometimes a larger figure with more information on it, even if it's a little bit more dense, gets across the message you're trying to convey a little bit better. So here's a motivating example, and these are all real examples from various things. So let's say you measure wait time in cancer patients and you want to show your results compared to the literature. So this is what your data set looks like. You have the studies, and here's your study here. And you've measured an overall wait time, and these units don't really matter, say they're days, months. You measure them in males and in females, and then you have some sort of understanding of how you've measured this. So some studies have done this as the mean and the median. So you want to display this. So a simple way to do that would be to just do a bar graph. So your y-axis is the study, the x is the wait time variable, and then you've added some fill here. So the problem with this isn't really ordered very well. So you can see our study is here. It'd be nice to have this as an order. So something you can do is reorder that as a factor. And there's this great function called factor reorder in the tidyverse, which basically says, give some levels to this variable study according to some other variable, in our case, wait time. So basically order this according to the wait time. And this gets rid of a lot of the manual ordering you may be doing right now with factors, because this, with the same code, essentially reorders everything. So now our study is down here, and we have all the other studies in the literature ordered according to the wait time. And I think a good place to start with bar graphs is to change them into lollipop charts to see if that helps, because there's kind of a lot of wasted space where you just have these large dark bars, and it can be difficult to tell the relative sizes of these bars. So you can do something like this, where it's the same data set, and instead you've now created a point at the wait time for each study. So that's this argument right here, geom point. And then to create these lines that extend from 0 to the wait time, you can create a segment with geom segment. And basically the arguments you give it are, I want X to start at 0, and I want it to end at the wait time. Make them relatively thin and make them gray. And that basically creates a line segment that starts at 0 for every study and ends at the same point as the point. And something that's important to know about ggplot, when you add the layers, they get added on top of each other. So for example, when I first made this graph, I had this geom segment after the geom point, and you could actually see the line going over the points. So the order that you put things in may have a slight difference. So if you're finding things aren't layering in the way you want, you can try adding them, the things you want in the background first, and then everything you add afterwards will be layered on top of that. So by adding the geom point, it sort of hides that segment behind it. So now compared to that bar graph, you have a lot more white space. So you have the opportunity to put text here, arrows. It looks a little bit less busy. And this is a little bit easier for your brain to kind of understand the differences between them. And it also gives you more opportunity to customize, because now you have this shape, you can change the type of shape you have to show information. So what I've done here is basically, if the study measured wait time as a mean, I made that a circle. And if it made it a triangle, if the study used the median. And you can just do that here. In my aesthetics, I have y, x. Now I've added another variable. So shape is equal to measure. Something else, I've changed the color. So I've added a new variable here. That's basically an if-else statement that if the study is my study called me 2022, give it a 1, otherwise a 2. And then I've added a manual color so that my study is in red. So it's a little bit easier to see. So just by switching bar graphs to lollipop charts, you get a lot more opportunities for customization. And you probably have to have less complicated charts. So something else we can do, because it's a little bit cleaner now, we can start to add annotations. So in ggplot, there's a geom v line, which is a vertical line, or h line, which is a horizontal line. And it's a very simple layer. It really just takes an x-intercept or a y-intercept, depending on which one you're using. So here I've added a vertical line at 15. And let's say, we're measuring wait time. There's some goal that the province has, people should be treated within this time, and you want to indicate that to give a sense of where these studies fall. And then I've added a text annotation here, giving it an X and a Y and a label. And so that's putting that kind of right down here. So if you remember earlier, we had data for males and females. And again, with the lollipop charts, you can kind of show multiple comparisons within each group. And something that's important with ggplot, if you want to show more information on a plot, or if you're struggling at all, I would say the first thing to do is, can you make your data any longer? Sort of the longer you make your data, the better, because every time you convert your data from wide to long, you gain an extra piece of information you can display on your chart. So if you're making really complex plots and you're kind of struggling, look at your data set and think, can I make this longer, and then use that information. So before we had a variable for the time in males and a variable for the time in females. And now we've made that longer using pivot longer. So basically take these two columns, time males, time females, and put them to a new variable called sex. And then it will automatically fill in the value into this variable here, value. Okay. So now what we can do is we have two measurements for each study. We have one for males, one for females. And so when we put geom point here, it's going to see 2 points now because we've made our data longer. So that's what we've done. So we have now males are in red and females are in blue. And so we can show within each study the difference in wait time between males and females. And we can adjust our geom segments. So now it shows the difference between them. So now we've added even more information. So you may, if you have data like these, think, oh, I would have to do a faceted plot, or I would have to put two plots on top of each other, or maybe staggered bars. But this I think is a much cleaner way to show differences in groups and across studies in a relatively, I think, attractive plot. So, and we've still maintained that difference between mean and median with the point shape. And so we can also add text to the layer. So this is some dense code that essentially afterwards you can take a look at if you want. But basically what we're creating is this plot. So we can create a new variable with the difference between them and add some text, and then we can plot that on top of each comparison. So that text is here. So you see I've created a text label that basically says, the difference, between males and females, and then add days to it. And then to create that gray box here, this is equivalent to what we showed before, where this is exceeding the wait time. I just drew a rectangle and colored it in, and then added some transparency to it, and then put in some custom annotations. So I think this is a great place to start when you have complicated figures. Like, do I really need to split this into multiple facets that may be confusing, or can I just do the plot in a different way and use some text to show a lot more information? So now we've shown essentially the difference between each study. We show how those studies compare, how they compare to some reference using this gray rectangle, and then adding some labels to it. Okay. So the next thing we're talking about is facets, and facets are essentially creating subplots in some sort of grid based on a categorical variable. So as an example, let's say we administer a survey before and after the pandemic, and the survey consists of 9 questions, and those questions are grouped into some categories about how they relate to each other. So the data are provided to you as 2 spreadsheets. So these are the before survey results, and then these are the after survey results. And then they give you some sort of key that basically says, okay, for a question, this is the category, and then this is the actual text of the question. So for a little bit of data cleaning, how would we combine these? So the first thing we can do is just bind them together. So basically put the survey questions before on top of the survey questions afterwards. And then to provide the names, we can just left join them. So basically it matches the data set based on, question 1 has this category and this question. So how would we start? Well, I think the first thing we can do is just create a simple box plot for each question. And so, before we were working with points and segments and lines, but all of these also work for box plots and violin plots, just provided an X and a Y variable, run it and see what it looks like, and then make adjustments. So here we want the questions of our survey to be on the Y-axis, and we want the X-axis to show the value. And if you provide ggplot the individual values, when it creates box plots, it automatically creates the box plot for you. You don't need to provide it the median or the range or anything. So we can see these are the scores for the different questions. But we have a lot more information we want to convey. We want to show the before and after because we surveyed the same people. We also want to probably in some way show how these questions fit into those categories that we know they represent. So we can try using a facet. And so you can facet anything in ggplot by adding this simple command. So here's one example. We use facet wrap. And then to give it the variable, you use tilde and then give it the variable. So our time variable had 2 levels, and those levels were called post-pandemic and pre-pandemic. And it will automatically fill in the top of the little box that shows the subplot with the name of the variable. So that's one thing you want to be careful of. If the name of the variable is sort of it's not very clean, it's not something you would want to present in a plot, just make sure you change that because it takes literally the values of that grouping variable. So this is a little bit better, but we probably want to show them directly beside each other. And that's one good example that facets are not great for direct comparisons. They're good for showing how things can be related to each other, maybe by over time or by some grouping. But if you want to directly show a comparison, it's usually better to put that information in the same plot. So what we've done now is create this plot, which doesn't look great, and we'll fix it. But basically, we've now faceted by the different categories of questions. So we have questions relating to anxiety, dejection, sleep, and an other category. And by saying fill equals time, now we'll automatically get 2 box plots for each question, the blue being post-pandemic and the red being pre-pandemic. And I kept in this kind of ugly plot because whenever you facet, sometimes the first result isn't really what you want and it doesn't look that great. And the most common reason is because the scales are not allowed to be set to free. By default, facet wrap will keep all of the same levels in all the little subplots. So if you have 9 questions, it has 9 questions in every subplot, even though we know there may only be 1 or 2 in some of them. So to fix that, we go scales equals free y. And you can have the y-axis be free, you can have the x-axis be free so that it's not common. And you can have, if you say equal free, you can have all of them be free. So now that we've set the y-axis to free, it's only showing the questions that are in that actual category. So this looks much better. But another problem with some of these facets, especially facet wrap, is it makes the size of each category the same for each one. And it can look a little bit funny. Like in this example, we only have 1 question other, so the boxes are much larger than in the other categories. And so you probably want them to be sized according to how many questions are in there. And that's actually not possible with the regular facet wrap layer in ggplot. There's an extra package you have to use to do this. And this is difficult to find, but it does exist. So it's called, the package is called ggforce, and the function is called facet call for facet column. And this gives you a nice option where, we have scales equals free y, which is from before. So we have only the questions that are in that category showing. But we also have this other option, which is great, which is called space equals fixed, as opposed to space equals free. And what this does is it makes the sizes of each subplot proportional to how many categories it has. And this looks much better. So now our other category is the same size, the boxes are the same size regardless of how many are in it. And I'll just go back to compare so you can see it's a subtle difference, but our other category is really just too large here. And so if you use this package, you can get some nice sizing relatively easily. And I've seen people try to get around this with having, dummy categories and empty data and stuff like that. And I think this is a better solution. So now we have some good comparative data. We can show before and after, and we have things grouped into categories. And if we have even more information, we can use something called facet grid. So facet wrap, accepts one grouping variable, and you can tell it how many columns or how many rows you want, to how to arrange the grid. Facet grid allows you to do two variables, and you're essentially creating a cross table. So let's say we also had data from the United States and from Canada, and we basically want to recreate this plot, but essentially have one column for Canada and one for the United States. So here we give it the rows, we give it the columns, and facet grid has that option for space in it. So you don't need to have a separate package for that. And so now we have, you just kind of go down. So Canada, dejection, results are here. And you can see faceting, again, isn't the best at comparing things. Like this isn't a great plot for comparing Canada and the United States, but it does present the information in a pretty compact way. So faceting is very helpful when you're trying to show multiple plots in the same figure, especially when you're trying to meet those strict manuscript requirements. So the next thing we're going to talk about are paneled figures. So the hardest thing with facets are really trying to get the sizing correct. And you end up sometimes struggling with making the plot look exactly how you want it to look. And it really can only control things in a grid. So you can only have really things in a column or in a row, and it just fills them in by the order you give it. But it's relatively limited in terms of, you can't inset a table into it. You can't, easily move things around or layer things or add arrows or other annotations. And it gets especially difficult when you try to add customization. So say you wanted to put an arrow or a text label, suddenly everything becomes a whole level more difficult when you're using facets, because when you go back to your code, you have to think about this piece here. Everything is now kind of grouped by this variable. In our case here, it's grouped by this category variable. So you can't easily just pass an argument that says, put a text annotation at this X and Y coordinates, because it's going to try and do that for all of them. And it might not be the same in all of the plots. The same location might be a different X and Y variable for each of the plots. You end up creating kind of mini data sets that you're trying to refer to, and it gets very difficult and confusing. So facets work great when there are clear categories that you're trying to show, and you're happy with things shown in a grid. But if you're trying to get more complicated than that, or show different types of data that can't all be kind of shown in the same data set, then panels become very useful. So here's a really simple example. So all of this is really based on the ggArrange function, and it's very easy to use. You basically give it the plots that you want to arrange, and then tell it the number of rows or columns, and it puts them beside each other. So you can really create the look of a faceted figure, but show different types of data, and it's a little bit more straightforward because you can customize each individual plot how you want it to look. add your customizations, add your annotations relatively easily, and then arrange them together. So sometimes even if something could be done with facets, if you have a lot to do to each plot, just code-wise, sometimes it makes more sense to create each individual plot. Okay, I'm happy with this one, set it aside, create this one, I'm happy with it, set it aside, and then arrange them together, as opposed to struggling with kind of the structure of a faceted plot. And you can label these. So by default, if you just put in the capital word auto, it'll add these A and B labels for you already. In this motivating example here is, say you have some data on the ages of COVID-19 patients. These are all obviously simulated and made up. So something that's very nice is if you combine faceting and arranging. So these work really great when you have sort of, say you have a distribution for an overall category, and then within that overall category, you have subcategories. This is a great way of showing both of those relationships. So even if you did this with regression or even modeling results, if you had a model in, say, your overall cohort, and then also wanted to show that in subcohorts by age, by sex, by some other variable, you can show the overall plot and then attach to it a faceted plot by those subgroups. So in this example, I have something I've called a large plot, which is basically just a histogram of these ages. And this represents all of the GTA. And then below, I have a faceted plot. And this is a separate piece of code that, like we saw before, we've just used facet wrap, for example, to show by city. And then I've taken those two plots and arranged them together and called them A and B. And when you use ggArrange, something else you can do is give them relative heights. So here I've used this heights argument, and I've said, okay, make the first plot here, large plot, 1.5 times bigger than the second. And then the end result of this is this kind of nice combination of an overall relationship, and then you look down and you can see smaller ones. And I hope this shows a good example of how this would be difficult to do just with facets, right? So sometimes I think, using them both to their advantage when they make sense, but, sometimes even just to prove how something would look using ggArrange first, maybe a little bit more helpful and simplify your code quite a bit. And then maybe going back and thinking, would a facet work? And you can also play around with different arrangements. So in this example before, to create this faceted plot all horizontal, I would have said, the n row, the number of rows is equal to 1, and it would have automatically done this. If I want it vertical, I would have said the number of columns is equal to 1. And when I arrange them together, I've said the number of columns is equal to 2. So this is how you can control how it's going to arrange everything. It automatically puts the labels in the right place. You don't need to specify that. And before, instead of the heights argument, where I want it to be 1.5 times the height, here we've done 1.5 times the width. So this larger plot is 1.5 times the width of this one. So another nice thing that makes it easier to conceptualize is once you arrange a figure like this is my code to make this figure, you can add additional annotations to that figure. And this is something that'd be very difficult to do with facets. So this package allows you to annotate the figure itself. So what I've done here is basically added this little italicized figure at the bottom right that says these data are all simulated, but you can use these to show, to add information about distributions or who was included and who wasn't in this plot. But essentially it gives you just another level of adding information to your plot that would be a little bit difficult to do otherwise. So the final thing we're talking about, and then we'll have time for really any problems people are having or questions, is to do inset tables. And I think this is probably one of the more challenging things to do in ggplot, even though it's common that people want to do it. And like anything in R, there are many different ways to do something. I think after experimenting with a few of them, this is probably the one that gives you the most flexibility and is the easiest to deal with. And this method essentially creates the table using a separate package, turns that table into an image like a regular ggplot, and then you can arrange it like you would any other ones. I think this is significantly easier than other packages that require a lot of work to even add just bars in between cells and things like that. So I'll go a little bit slower for this part because this one can be a little bit more confusing. So basically this uses the flex table package, and that's what allows tables to be converted to rasters, which are essentially objects that can be added to ggplots. So let's say the example here is you have some sort of typical like cancer data sets that describes patients, and you're interested in studying the effect of the grade of tumor, basically how aggressive the tumor is. And as part of this plot that you want to be large and efficient, you want to show a little descriptive table inside the figure. So the first thing we can do is add the other figures we want to do. So this top one is just a scatter plot, and we've colored it by the grade of the tumor being no or yes. And then the second one here is a combination of a box plot and you can add the jittered points to it, which, and these figures are quite common now. Probably if your data set is small, it's better to show the individual points on top of the box plot rather than just adding the box plot. And so these are separate plots that I've named. So this one's, I've called it scatter plot and box plot. I've arranged them together. I've said I want a single column, so it's put them vertically like this, and I've asked it to automatically label it for me. So it's given it the labels A and B. So now let's go to our table. I hope it may not be hard to see, but so this package creates summary tables. So the way this works is you give it your data set, and this data set is called cancer. And the main function that creates this table is called table summary. And you include all of the variables that you want it to include in the table. And in this case, I've included everything except for the patient ID because I don't want 80 categories for that. And then I've said I want to create this table by this variable of high grade. And so when you do that, it'll create this part here, just this. So I have a table that says, no, so 60 patients do not have high grade tumors and 20 do. And it creates this little table. And then this package allows you to essentially add layers to this table, which is very similar to how ggplot works. So that's why I think the methods kind of work together. You build them in a similar way. So the first thing I want to do is add a p-value. So I add a category here, and this automatically creates this column that does the comparisons for you. And for categorical variables here, it'll use chi-square tests or exact tests depending on the size. It does this all automatically. I want to bold the p-values that are less than 0.05. I want to bold the labels here. So it's going to bold the overall categories. So for, it's going to bold hospital type here, and I have 2 different categories within it. And then when I'm happy with that, so everything up above this line is creating the table. When I'm happy with that, I want to make it a flex table. So I say as flex table, give it a title, and then put this vertical line. So, okay, I have my table, I'm happy with it. And the great thing about this flex table package is you can turn it into an image. So there's basically a function to say, save it as a raster, which is a type of object. And then we're going to plot it in a slightly different way before. So when we did the panel figures before, we used that function called ggarrange that essentially, I have plot 1, plot 2, plot 3, tell it the number of columns and rows, and it creates it for you. If you want to be even more customized and you want to put things in particular places and exactly specify where you want, you can use something called ggplot2, which is another package in R. And the way this works is, imagine the final figure you want to make is a 1-by-1 grid. So this is sort of your plotting area. Everything you add to it, you give it a size. You say, this is where I want the left corner of that plot to be. You give it a height and a width, and that's where it plots it. So this is probably the most customizable way you can do this. So if you're even unhappy with how ggArrange is doing it and you want to put things on top of each other, or you want to have a plot with a tiny table in the corner, this is how you would do that. You would use this giant plotting area as sort of your canvas, and then tell CalPlot, okay, I want a table to be exactly this height, exactly this width, and starting from this corner. So in this example, I've said, okay, draw a square. The left corner is at 0.5, 0.5, and it has a height and width of 0.4. So this is how we do that. So we start with this here, which is ggdraw. So that creates that sort of blank canvas, that 1x1 square. And then the first thing I want to do is draw my scatter plot. So that's this one. And you can see how this works. So you have to give it the left hand corner here. So let's say I want the left hand corner to be at x is equal to 0, y is equal to 0.5. So that's right here. I want the width to be 0.4. I want the height to be 0.4. So that plots that. Okay, now I want the next one. So I'm going to plot my box plot. So same thing, x is equal to 0, y is equal to essentially 0, same height and width. And then now I can plot my table. And I give it the left-hand corner that I want. Then I add the labels, and this is the sort of final result that you get. So this is probably the most complicated version of this when you want to add it all together. But this is probably easier to do than to use ggArrange, even if the code looks a little bit simpler, because this gives you much more customization, and you can play with the sizes of everything so that it exactly corresponds to how you would like. That's it. It was a little bit faster than I thought, but I guess it gives us time for some questions or to review anything that was maybe a little bit too fast or confusing. So there's some great resources for R. There's a gallery of graphs that gives lots of different examples of chart types and sort of helps you brainstorm, how could I show this better? And then there are books. Hadley Wickham wrote essentially all of tidyverse and ggplot. So that's definitely the Bible of ggplot. So now we have some time for questions and a bit of time to go over anything that was confusing, or even open R and play around with something.
Thank you, Matt. That was excellent. Does anybody have any questions or comments? I think Matt is willing to answer or give us advice on maybe problems you're having with ggplot. So this might be a great opportunity to ask. Oh, Tony, go ahead.
Thank you. Excellent presentation, Matt. I'm wondering if you just go back to one of your first slides where you indicated the different packages. Could you just sort of highlight or elaborate on what does what?
Sure, absolutely. So tidyverse is a large group of packages that's essentially a new way of manipulating data in R, which would be a little bit different from the base R people are used to. So within that, there's a lot of different packages. So there's packages to import data, but I think critically the two that we care about is it has ggplot in it. So if you just wanted ggplot, you would load ggplot2, and then dplyr, which is the grammar of cleaning data. So that's at least for our code, what you'll need for that is this pipe is really the most important part of that. Although R has added a pipe, I've not really used it, but I do know they added one recently. ggsci is a package that has color palettes for academic journals and TV shows actually as well. They have oddly those, but if you're submitting to things like JAMA or NEJM or Lancet, some of the really most common ones, they have those. And they're just good palettes in general. ggpubr is an extension of ggplot that for our purposes, the most important thing is that it has that ggArrange function. So that's what people are using to arrange. And calplot is that really highly customizable one at the end that lets you plot according to coordinates. But if you look at ggpubr and you look at the code for ggarrange, it's actually just calling this inside of it. So it's really just using calplot to plot everything inside of it. It's just a more convenient and compact way of doing that. But really, it's kind of ultimately doing the same thing internally. So that's why if things get complicated, just sucking it up kind of and plotting everything manually sometimes gets you better results. And then flex table and GT summary are the two packages that allow you to create tables. So GT summary creates the descriptive table, and then flex table allows you to turn it into an object that can be plotted.
Thank you.
Anyone else?
I could jump in with a question. I don't actually have it in front of me, but I ran into a problem while trying to label graphs pretty recently, where I wanted a specific font and was able to get it going for all my axes and things like that. But by using geom text, I was like banging my head against the wall, like getting the geom text actually on the graph to carry over the same font that I applied everywhere else. Can you comment on that at all?
In terms of controlling the fonts, it's a little bit tricky because if you're adding layers, it's controlled often differently than the theme of the plot, which is usually the challenge you run into. So in the bottom where you're adding theme, so in here where you're controlling everything, you can control the text here. You can go like, axis text X is element text. And then within that you have bold, face, font, all that kind of stuff. But that often doesn't apply to the actual layers. And the most common when you see this is if you set the font size, for example, in your theme, it sometimes won't actually change the font size in the layer. So you sometimes have to do it in both. And you kind of end up having to go into the arguments for both to see if geom text has an argument for that. A way around it that you could try is to manually plot them all as annotations and write it almost like a loop from a separate data set to sort of like automatically plot these as all annotations, because I think annotations will inherit whatever you put in theme. But yeah, it's tricky. I think fonts and like italics and bold get really complicated in ggplot when you're trying to only control one or two of them.
Thanks. Yeah, I'll try that annotation idea because that's exactly what I was running into. Theme was working for the axes, but not for the geom text.
Yeah.
Matt, I had a question. I think at some point you used my theme to create that. Can you, was there a slide where you actually created the my theme, or was that done outside?
No, I did it outside and I just hid it so it wouldn't be a lot of code. But basically, yeah, thanks for mentioning that. When you're creating a lot of plots and you start to sort of repeat yourself with these themes. So the one I always do is you get all of these grid lines. I like to remove the minor ones with this command. Panel grid minor is element blank, which is essentially a way of deleting something in the theme. You can list all of them together. So you can say, my theme, and then just like you were creating a data set, listed all the themes, and then you can add my theme to the bottom of this, and it will apply that theme to everything. So, and in the extreme example, like sometimes entire journals or like companies that use this internally will have a company theme that you have to add. So.
Got it, thanks. Stephen, go ahead.
Yeah, first of all, thank you so much for such a nice and clear presentation. It's always really, always nice to see it done that easily. On my hand, I'm still really at the beginning of learning how to program in R and learning how to do some of these illustrations. And do you have any specific resources that you find are very helpful, especially for beginners, to kind of move forward? And by that I mean a one place that would give us the most amount of information, because I find myself just opening a lot of Google pages and reading through a lot of different things. And sometimes I find it better if there's a one specific spot.
Yeah, for sure. And it's tough because a lot of the resources are like solving specific problems, which are great if you have that problem. But if you're just trying to learn, it's usually not that helpful. I think in terms of like a guided thing that doesn't cost any money, the Hadley Wickham book is probably the best one. So his book on ggplot here, this is a clickable link, and we can send this out. And it's essentially like an online book that you can work through. And that one will definitely go over all of the basics and is has exercises. And like if you can work through all of that book, that goes like even beyond this talk as well. So that would probably be the single best resource. In terms of something that's a bit more interactive that does cost money, I use DataCamp in the beginning, and not to necessarily recommend any specific company that offers classes or anything like that, but I personally found that very helpful in the very beginning. But so yeah, I think those would be pretty good, like Hadley Wickham's book, and then I liked the DataCamp courses, but I know that's paid.
Great, thanks a lot.
Okay, anybody else? We still have a few more minutes, so now is the time to ask. And the slides and Matt's code too, I believe, will be shared on our website shortly after this presentation.
And if anybody runs anything and they have any questions, please just email me. Happy to go over anything.
Okay. Well, thanks, Matt. I think that was a very nice workshop. I learned a ton, actually. And I'm looking forward to use some of your tips in my future work. And yeah, so thanks very much. Thanks everyone for coming, and check out our website in a couple days for the slides and the code and the recording of the talk. So thanks everybody.